Hi, and welcome to this video on virtual tables, real benefits. Hey, I'm Eric, and in Business Central we actually have several different types of tables, and we all know the the real tables, the customer table, vendor ledger entries, and such. And those are very real tables. Then we have some not so real tables, and I got a question the other day, and got me thinking perhaps should do a short video on that. So let's dive right into it, and let me show you what I'm talking about. So here is my good old Visual Studio Code newest version. And we'll start by looking at the, see if I can make this bigger. There we go. Look at the symbols that we have loaded. I just fired up a new extension here on a version 17 sandbox. And we get some different symbols, and the one that's interesting is the one that's just called system. So let's take a look at that, and I can double click on this one and get the content of it, because I have the where is it, this guy installed. So the tool I'm using right now is the AZAL DevTool/AL Code Outline. Wonderful name, Andreas. But it's a very, very cool tool, and I did a video on this at some point, so you can go find that. And while you search for that, hit subscribe, because that really helps me a lot. Anyway, one of the benefits is that I can browse the information in a symbol file, and here are the 2 billion, or is it 20 billion? I can't really remember. No, 2 billion number objects, and some of them are real, like the company table. That's actually a table, and it has fields like any other table, and it's in the database, and all is good. It's of course not per company, but then there are also some other tables down here. Let's look at the first one I want to look at is the integer table. So what is this? So if we look at this guy, and let's look at what do we actually have. So you can look up here. We can see that there is just one field, number, and the primary key is, well, number. So what this is, because if you go and look on the SQL Server, you install BC and go through all the things just to look at what tables you have on the SQL Server, you cannot find this table. It does not exist. So this is a virtual table, and means that it's generated on demand. So there's no place in memory where this table sits with all the 4 billion possible integers. It's just a virtual table on demand. So how does that work? Let's try it out. So let's create a new page here. Let's call it the integer page, so we know what we're talking about. Let's get rid of all this. So this is a page. We'll give it a number. And let's say that the page type here is a list. And we want to do the source table is the integer table. And then we'll do layout, and we'll do the content area. We'll add a repeater, and we will add the famous field called number. As you can see, that I actually think we can try it out in a minute. the new fields that are in 17. So system modified at system. I think. Let's see what I think the compiler is perhaps a bit too suggestive. But let's try it out in a minute. Let's first add the number. We'll put a beautiful caption on this. Is the caption. There we go. Application area, because we have to. And now we also get the squiggly line here because there's the implicit width. And even though this is version 17, Microsoft, if you're watching this, I'm all for adding the rec, but you were the guys who generated this piece of code with an error in it now. So go and be a friend of mine and then just change the generator so it actually insert the rec here also. Anyway, so this is great. We have 19 codes of almost nothing. Let's run. See what happens here. I think I did not set the right start page, so let's go back and see if we have that in our launch JSON. We do. I was wrong. And I need to log in, of course. And we got some data starting at a -1 billion. So maybe actually I was wrong saying there were 4 billion possible integers. Maybe there's some 2 billion from -1 billion to +1 billion. If we do Control End, we will get to that one. So typically when you use this table, you see, so it has all possible records. So the typical usage would be that, for some reason you need to process something there's 419 of it. So in this case, since we're in a page, we can do view where number equal filter, and we can say, okay, we need to go from 567 to 714. Okay, I guess that's the range. Run again. So we're just applying a normal filter as we would on any other table. And now this is the numbers, the records we're getting. And since 714 was the last one, that's the end of it. So a very, very convenient way of getting something that acts as a record, even though it's not. So I thought I would show you a little thing. So let me actually, you see, let's go back here and then we'll add a dictionary. Dictionary of integer and text. So how do we browse a dictionary? Well, we don't. There's no way in the UI to add a dictionary. So we cannot say source table is our dictionary. But we can use the integer here. So let's actually do trigger on open page, and as usual in a TV kitchen environment, there's a bit of preparation. So I actually sat down and just typed a bunch of dictionary.add commands. So I'm adding something here. So some names. So let's change the filter from, let's go with -7 till 40. That's a good filter, right? And what I want to do now is, instead of showing rec.number, I'm going to use number as the parameter. In this case, we can actually be fairly clever and say dictionary.get, and let's get number. So dictionary.get, and then I will put a rec in front of this. So the get has an overload, says give me the key, I will return the text. And in this case we got, let's change Peter to be -1, and let's change Viggo to be -3. So hopefully we should now get a list of names. Let's see, run it, and let's see what happens. Exciting. Anybody notice that version 17 got a new rotating circle thingy instead of the pulsating dots? This is taking too long, I think. Let's see, did we do anything out of the ordinary here? I don't think so. Ask it to reload. I think we broke something. Not on purpose. Let's go back and see what if it's the funky filter I'm setting here. Let's do 7 till 10. 7 till 11. Haha. We might actually put the filter in quotes. Let's see if that makes a difference. That made a difference. Oh, so we got some names. Okay, let's go with the -7 to 40 again, because I was actually trying to prove a point before I got misled. So now we got nothing. So what is nothing in this comparison? Let's go back and see. So what happened here is that is our dictionary.get, if it cannot find a value, it returns an error. So let's go back and put this back into 1 till 33 and see if we can do this. 1 till 33. Come on, integer, you can do it. Let's see what we get now. And now we get all the names. So what happened here, and this is interesting, is that our dictionary.get returns an error if the key is not found. So if a function inside the repeater is returning an error, the page is just broken and cannot work. So if we want to make this more resilient, we can go back and then we can create a procedure here, get value, and we'll just pass an integer here and we'll return text, and then we'll do if dictionary contains key I, then exit dictionary get I, and then change this one to, instead of dictionary get, to get value. And let's try again. Then what was I did? I did -7 till 40, and then we added some minuses, so a couple of these. There we go. Let's compile this again. And now we have holes in our data because we had rows where it did not return anything. And the last one was Harry, and then up till 40, whatever it was. So we can now actually control and show data that is not necessary in a table. We can show it as it was a table. So that's one example of this. I think I'm gonna do one more just to bring home the idea. So there's several other tables here. Some of them are no longer basically in use, like the file and drive, because there's no files and drives in the cloud. So those were only relevant on-prem, like the file virtual table. You would set the filter on the path, and then the virtual table would by magic have the file names that are in that path. Another fun one that I tend to use a lot is the date table. So let me show you. It kind of works the same way as the integer, which is very convenient. So you have a let me see. Haha! I remember at this point. Let's change the startup page. So date virtual. And we'll go with a page type equal list again, and now the source table should be date. And let's actually do the exact same thing. So we'll go layout area. Wow, area 51, area 9. Wow. Okay. This is late night in British Columbia. It's pitch dark outside, and we're wearing sunglasses. No, sorry. I'm just at some point you get stir crazy sitting down here in the basement. Anyway, back to typing. So now the field name so in the date table we have way more fields than in the integer table. So we have a period type, a start and end, and a number, and the name, and all these can be used to, if you're in a report, you need to run something over a certain type of ranges. You can just set the filters in these, and it will build up the data for you. So let's just start by adding the period start here. Caption equals start, application area equal we have to, and we got the missing reg here again. So what's in period type? Let's look. So let's do a source. Well, let's actually just run this now. So this is valid code, I think. So let's run it. See what we get. So we get the first date in the system is January 3rd, year 1, which is a long time ago, and the last record is January 1st. Yeah, 9,999. So after that, BC will break, and it'll break hard. But I'm long gone at that time, so I'm okay with that. Okay, so let's add in the period type. Let's see what's in period type. Just look like dates. So can we get this to do anything else? Let's see. What if we add a source table view where period type equal constant? What are the options here? So the options are date, month, quarter, year, week. So let's do week. Now we're asking to only see weeks. So this is interesting. Let's see, let me blow this up. So now remember the first date in the table just a minute ago, or less, was January 3rd. So now the first record in the table is period type week on January 8th. So just by adding another filter on this table, we get a totally different content. So in this case, we suddenly got a table of weeks. And you know what happens if I change this to a month and go. I don't have to show you guys, but I'm showing you it anyway because that's... So now, so we can see that we cannot get to January 1st, year one. That's simply not in there. So the first month we get is February 1st, which is a wonderful date. But that's another discussion. So by applying filters, the content is changing. So this is matching, right? We apply filters, and the filters we apply, suddenly the data we need is in there. I think this is pretty cool and very, very useful, especially in reports and statistics and stuff like that, where you suddenly need to work on dates or work on periods. I use that a lot. Somehow I use the week thing more in Europe than I do in North America, but that's probably a whole other discussion. Anyway, so that's two examples of virtual tables, tables that aren't really tables, but you work on them as they are, as if they are tables, and they behave like tables, but they're not sitting anywhere. The content is generated at runtime for you, and depending on what kind of virtual table you're working on, applying filters will change the content. And as I told you, the files table used to be a great example of the magic of this, but the date table kind of do the same thing. So yeah, that's virtual tables. If you're using virtual tables and other than the two boring one I just showed, let me know in the comments below and tell me how you use them, so you can let the other viewers learn a bit about what you do. And remember to subscribe while you're down there. So until next time, have a wonderful day.